Welcome to this episode of Building Better, your guide to the future of Britain's interior spaces and the trends driving UK construction along a better path. From cutting-edge designs to new technologies to essential skills, you'll find it all here. And today we're kicking off with a look at Better Tomorrow, which is taking place as we speak right here. Welcome to the Energy House project. Here at the University of Salford, an expert research team have built something very special. It began with a facility dubbed Z House, a place to test energy efficiency and best practice principles for interior spaces. But as the facility grew, it became known as Energy House 1, and more recently it's been joined by Energy House 2. Together, these test labs are a hotbed of research and analysis, environmental chambers that put the practices and principles of building to the test again and again. They're rigged to simulate wind, rain, snow, and even incidents of solar radiation, and designed to measure a wealth of variables. The Energy House project is focused on how our spaces can handle every eventuality while minimizing and optimizing energy use. Groundbreaking research goes on here, and we're here today in the great city of Salford to see it firsthand and to get an idea of what's in store in terms of innovation and sustainability in our spaces. For our first stop, Energy House 1. Will, tell me about the journey to Energy House. What's it all about?
So really, what we tried to do when we started was to understand how we could help people live low carbon lives in their homes. And an opportunity came to use this space, which used to house a Van de Graaff generator, to do something a bit different. So in around 2010, we came up with the idea of putting a whole building in an environmental chamber. And the reason we wanted to do that was really around retrofit, so which is why we've got a Victorian end terrace. Hard to treat, there's loads of them in Greater Manchester. And the reason we did it, because the way we were testing things before is either we take a little bit of it and we test it in a lab, but we know when we put things together they don't always behave that way, or you do a field trial. And the difficulty with field trials is they take a long time, so you can be waiting 1-2 years. If you're an innovator, that's no use to you. You can't wait 2 years to make your business and move it forward. So what we did is we built a whole system, so we can do fabric systems, controls, anything really that you would put in a normal house, and then test it under controlled conditions. And that made the big difference because we could do a repeatable experiment at the whole house level. So we can test the house as is, make the changes, be it, a small energy efficiency innovation or a whole house retrofit, and then test it again under exactly the same conditions. And that really kind of opens up a quicker understanding of what works. And that's really what we're all about, what works.
Accelerating testing.
Absolutely, absolutely. So if you think about a field trial, you have an innovation, 100 houses, 2 years, maybe a few £100,000. What we can do here is, in a couple of weeks, understand the difference that it makes. Now, you may need to still do a field trial, but at least you know whether it's worth it. I think the other thing we can do is, you can do things wrong, you can experiment, because you can't do that in people's real homes. And that's a real benefit.
So this entire space is heating, cooling?
Yeah.
What weather conditions can you simulate in here?
Okay, so what we could do here is we can take it down to about -12 up to +30. So what we sort of think is a European maritime climate. And the climates are obviously, bearing in mind this is sort of 15 years on, so climate's changing all the time. We can also rain, we have a wind machine, we have solar lamps that move around, so we can move the sun around the building, and we also have a snow machine as well. Largely what we do is temperature, a little bit of rain as well, but that putting on that solar when we start thinking about overheating, that's becoming a bigger and bigger issue.
So you can pretty much simulate any weather condition in this room at any time of the year?
Yeah, it's a proxy. It's not going to be exactly the same as the weather. The sun, it's that's a lot of energy. And so we're trying to get as close as we can to it. And that really does help us understand how things will perform in different conditions.
This is basically a complete house.
Yeah,
built as a normal terrace would be built.
Yeah, so what we basically have is an end terrace, and it's exactly the same footprint as the first house I ever bought in Manchester. And we have half a house next door, so that contains some of the mechanical and electrical equipment and a small testing lab there. So we can replicate what goes on next door, because obviously these don't exist on their own in the real world, they're part of a row. So it's a suspended timber floor. The bricks were reclaimed from a house that was knocked down about a couple of miles from here, from a place called Langworthy in Salford. The bricks were laid by a bricklayer who must have been in his mid-70s. He said he'd not laid bricks in that bond for, since he was 16. And then it's lath and plaster. We tried to get it as close as we could. But obviously a lot of these houses are upgraded as well. So the original, we had single glazed windows and a gas combi boiler. We've upgraded really because we see more double glazing now, obviously. And then some loft insulation. And that's kind of our base case. And then we make changes to that.
So that's the standard model, and then you trial all the things to improve it in many ways. What are the main things that you've seen the biggest responses for, or the most kind of eye-opening sort of investigation or discovery?
I think we've seen so many different things. So, and I think the usefulness is, you can take those big projects. So one of the first big projects we did was a whole house retrofit with Saint-Gobain. And so basically the house was completely retrofit, so loft insulation, doors, windows, underfloor membrane, solid wall at the end, at the gable end and the rear, and then internal wall insulation. And then we took one thing off at a time and tested it under repeated conditions to see what the impact would be. And I think that repeatability, that's really, really powerful. And then I suppose that for us, was then when people really understood the power of what we were doing. It was so new. And then in between that, we've tested everything from air source heat pumps, boilers, controls is really just basic controls and the difference they can make. I think the one thing that we've done recently, so we did a piece of work with Nesta on the turning down of the boiler flow temperature. And that was, for us, it wasn't a massive test. So we did it 80, 75, 70 and so on. And just recognising that you could just reduce the boiler flow temperature with a small amount of loss of comfort, but save massive savings, and that was during the cost of living crisis. So actually, I think we estimated that about 3.5 million households had done that.
Wow.
And that's a massive energy saving. So it's that power to do things and also to communicate how things work. You bring people here and show what you're doing in a way that you're not always able to do if it's just a lump of insulation in a lab.
Is this unique? I mean, does this exist anywhere else?
Well, other than the other one we've got. This is now Energy House 1, so it was originally the Salford Energy House. And we saw it was the first time anyone had done it. And really,
anywhere? Anywhere
in the world.
Really?
Nobody had built a house and put it in an environmental chamber. So we searched and searched and searched. And we did a lot of news, a lot of press when we first launched, and nobody came back to us. There were lots of rooms, there were lots of test labs for vehicles, but nothing connected and dedicated towards the built environment. And so, for us, we really, when we started thinking about Energy House 2, the reason we started thinking is people were approaching us and saying, we're interested in building something. So, we invented it, so we wanted to kind of push it forward as a method of really understanding the built environment and energy efficiency.
So Energy House 1 is about retrofit?
Yeah.
And Energy House 2 is about new build?
Energy House 2 is about everything. So what we've got here is it's not built for purpose. So there are things, Energy House 2 is about fixing the things that we would have liked to have been able to do here. So you can see it's on a concrete block. Energy House 2, you can dig your own foundations. So the idea behind Energy House 2 was really, this is always going to be here. And it's still in massive use today. It's still 6-7 months if you want to get in and test something. But Energy House 2 was about having 2 greenfield sites and people coming to build whatever they wanted to build. And so, yeah, we've got new building there at the moment, but we've done refugee tents, so heating refugee tents. We've done flat pack buildings, we've done conservatories, we've done construction, site cabins. So there's a lot of flexibility in that, and that's really what we aim for with Energy House 2. But Energy House 1 still has a little special place in our heart.
So today we've seen just what goes on behind the doors at Energy House 1, where retrofit thinking can positively impact the future of our spaces. Join us next time and we'll be taking another step forward with the advances happening at Energy House 2. See you on the next Building Better.